Okay, so good afternoon, ladies and gentlemen. And what will be the first example? As mentioned earlier, I'm going to stick to the first topic for the day, which is number patterns, sequences, and series. But I'll also probably mix things up a bit as I go along, just to keep things interesting for myself. But as promised, here's the first example. So I pulled this from the 2017 exam paper. It's got two parts, as you can see. This was the only question on this topic in this paper, and it was worth 18 marks. So a little bit more than 10% of the paper was on sequences and series. Okay, so we're going to actually go ahead and start with the first example. And what I want to do is just choose a different color, maybe make things a little bit more interesting. Okay, so the first question is to determine the constant second difference of the sequence. What's important here that immediately jumps out is this concept of the second difference, right? So you know you have to go down 2 levels. So we're going to start off by doing the first level. And as the name said, difference, well, that means you just got to calculate the differences between the different numbers in the sequence. So we're going to start with D1. This is the difference between the first and the second entries of the series. D1 there. And that equals, well, the second term minus the first term. So that'll be minus 4 minus 5. And that's just, well, minus 9. Right? Okay, we do the same for the second distance. That's D2. And D2, well, that's actually wrong. I don't want to calculate it like that. Let's just see how I'm going to erase it. Okay. Let's see if it's fine. It's not. Okay. Second distance term, D2 equals, well, now it's the difference between the third entry and the second entry, right? So it is minus 19 minus 4. Okay, and that's, well, if I write that out very concretely, that turns into minus 19 plus 4, and that's minus 15. Okay, so we've got 4 numbers in the sequence. So we've got 3 distances that we have to calculate. Okay, so third distance. That is minus 40 minus, well, minus 19. That's minus 40 plus 19. That's minus 21. Okay, so first level has these 3 entries. Okay, if we can draw that more concretely so that you sort of get a clear picture of what's going on. So at the top level we've got 5 minus 4. We've got minus 19 and minus 40. Okay. And the second level, or the first level then, first level down, we have minus 9. This is the first level. That's minus 15. And that's minus 21. That's 2. Okay, minus 21. Cool. But the question asks, clearly stipulates the second level. So we have to go 1 level down. We're going to do that. I do that in blue again. Cool. So second level down. Okay, so we need the difference now between these two numbers. Okay, so that is difference here equals, well, the second one minus the first one, minus 15 minus 9. It's minus 6. Boop. And ladies and gentlemen, the difference between the third term and the second term, well, that's minus 21 plus 15. That's also minus 6. Okay, cool. So if we complete this graph, then we've got, well, the difference between these two terms, minus 6, and the difference between these two terms is minus 6. Okay, so that's basically the gist of the first question, with these 5 answers being exactly what they wanted, right? These 5 answers over here. Now, this brings me to an important point as to how you actually learn mathematics. I made a point not of making the slides with neat looking PowerPoint presentations and stuff, because I really do think that to learn mathematics you have to write it. Even still, me, if I really want to think, I have to write. So I suggest you follow these slides by also writing with me and understanding as we go along. Okay, so these calculations, very simple, worth 2 marks, right? Okay, cool. The next question, well, they want us to determine the nth term of the pattern. Okay, so what they basically want is just a generic term describing this pattern. But they also give us a clue, and I've shown this in this red box over here. They say that it's quadratic, right? So what we know is, in general, the first thing that's important is the following. So this quadratic number pattern has a general form, looks something like this, right? That's our end goal. That's what we have to write. It's no biggie because they gave us exactly the form it should be. So we know we have to end up in our end answer at that, right? Already off the bat here, we know that, well, gee, there's like these 3 unknown entries here, or unknown parameters, and we have to now compute them, right? So the first thing we can do is we can say, well, I like to, let's think about this. Okay, I have this, and then I can compute the first derivative of this term, and that's 2n plus b. Okay, and the second derivative of this term is, well, did I do something wrong? Yes, 2an plus b, and the second derivative is just 2a, right? We know that. But we also know from our answers here what the second difference number or value should be, right? So that's minus 6. So we can go, well, this minus 6 here, we know that that is 2a. And so to solve a, we know, well, it's minus 6 divided by 2 is minus 3. So that was the first step. So we've got this guy over here. Check. Cool. So now we're stuck with, well, let's write this out to be a little bit more concrete, right? we've got minus 3n squared plus bn plus c. Okay. What we have now is kind of this equation here. It's still got these two unknowns. And we also have a lot of entries here. So, if you pause for a moment and think about how you would solve unknowns, well, actually you need a system of equations, right? That's what I would do. I would set up a system of equations. To solve two unknowns, well, you need two equations. And then you can solve B and C simultaneously, right? Let's see if that works. That's one idea I have. We're going to run with it for a while. So, let's do first. Yeah, let's do first equation, right? So T1. Well, T1 I know, that's the first term there. That guy over there is 5, right? But that's also equal to, well, minus 3, which is A, and n, which is 1, right? Plus b times 1, that's also 1 squared, plus c. Okay, that's our first equation. By the way, once we've done this, we score 4 marks over here, right? So it's easy to get it right. They tell us it's quadratic, so we know the form of this equation. Already off the bat, we could solve A, because we have this entire sequence. And now we're going to solve B and C using simultaneous equations, right? Okay, so term 2 equals, well, that equals minus 4. And that is minus 3 times 2 squared plus b times 2 plus c. Okay, that's equation 2. That makes sense? Everything I've done here is this first equation here. Let's take it a little bit slower. And this first equation here is related to this first term of the sequence. Okay. And the second equation here is related to the second term of the sequence. So I've done nothing weird or strange. I've really used all the information I have just as is. Okay? And again, I'm going to say it. You've got to read the question well, because the clue to this entire solution is this word over here. Okay, cool. So, 2 equations, 2 unknowns. This should be pretty basic stuff. Let's see. I'm going to rewrite one, right? So I'm going to say, let me see. I'm going to say B plus C, right? From 1, B plus C equals 5 plus 3. Okay, and I'm going to rename that 3. And we're going to put 3 into 2. Let's see how we go along. Okay, so I've got 2 let me just rewrite this. I've got B equals 8 minus C. Okay, that's what I'm going to use. So I'm at equation 2. I've got 2b. B I'm going to replace by 8 minus C. I've got plus C. And I've got that equals minus 4 plus 3 times 2 squared. Okay? Did nothing weird. Just have a look. I just literally put this. Let me show you. Literally took this and I plugged it into this equation here, right? Okay, solving it. Super easy. And the solution to that is C equals, well, 14. You can have a look. Go through it yourself. Okay, I pop C equals 14 back. Oh, that's wrong. C equals 8. Let me just... Erase. Cool. C equals 8. Sorry, guys. Okay. I popped that back. I knew there was something wrong. B equals 8 minus 8. So B equals 0. Okay. There's two answers over there. 4. We've got A, B, and C. So we're ready to determine the nth term of the pattern in quadratic form. Tn equals minus 3n squared plus 0n plus 8. And that's the solution right there. Okay, 4 marks. If we take some time, just quickly reflect back. As I said earlier, I'm really going to scratch on this now so we get a clear overview of what was the thinking here. We've got this guy over here, which says that we have to draw up the tnth term, and we therefore have to use this equation of this form. We have 3 unknowns that we have to solve, but we also have the sequence of numbers, so we don't need to be scared or anything. We just have to take some time and do it correctly. Okay? The first thing is we derive this tn term twice to arrive at t2a. Okay? And we know that because from previous solution we got this minus 6 as the second derivative, we could calculate this a as minus 3, plugged it into there, bloop, and we still had 2 things to solve, B and C. And we decided, because we have so much information here, we're just going to do it by solving 2 equations simultaneously, 1 and 2, right? We defined a new one in which we completely just defined this variable b. We plugged it into equation 2. We could solve c and we could solve b. Now, granted that you have to work correctly all the way and not make mistakes like I almost did. This is pretty easy, right? Okay. So, the next question, they want to know, and this is the last one in this series, and they want to know for 3 marks, which term, so for which n, will this value be this? Wow. I've now sort of cheated because they didn't give this, right? They said for which term will the pattern have that value? But from the previous question, we sort of know that this is the solution to the terms, right? So we know that minus 25939, 25,939 equals minus 3n squared plus 8. Because we got this from 2.1.2 as a solution, right? Okay, so we have to get this n by itself on this, either the left or the right side of the equation. We're going to do it on the right, I think. Or on the left, sorry. 3n squared, so I just took it over. I have equals 8 plus 25,939. Okay. I have n squared equals 25,947 divided by 3, and to get n, I take the square root of this guy over here, and I get n equals, well, minus 93 or plus 93. Okay, we know this is not really possible. This is not applicable. And this is the term. So the 93rd term will have a value of minus 25,000, blah, blah, blah. Cool? 3 marks. Easy. And this is basically, as you can see over here, just sort of the root of a quadratic polynomial. And you can easily do it, calculate it using your calculator, right? And computing the square root. Cool. That's that. Ooh. I thought I'd throw in a bit of a joke so that I just test whether you're still with me.